Hello everyone, my name is Lotfi, and in this video let's talk about an element's properties depending on the structure of its atom. Okay, and these are the main subjects for this video. I hope you enjoyed this video, and so let's get started. Okay, so as you might know, each element consists of a certain type of atom that is of course different from the atoms of any other element. Okay, so let's just think for a moment that this wasn't true. Okay, then in this case gold would be the same as a plain old rock, or even better, an iron, okay, or copper or other element. Okay, an atom is the smallest unit of matter that still retains the properties of an element. Okay, so it's kind of like a miniature version of that element. Okay, and as you know, elements are so small that you can't even see with a microscope. Okay, and the scientists symbol atoms with the same abbreviation, okay, that is used for the element that is made up of those atoms. Okay, this doesn't make sense, I know, so you will understand better with an example. Okay, so for example, the symbol C, okay, stands for both the element carbon and a single carbon atom. Okay, and this is a carbon, but I don't know which one. Okay, an atom, but I don't know which one it is. So yeah, it's an atom. It's a diagram of an atom. Okay, so now let's talk about the subatomic particles. Okay, although the atom is the smallest unit having the properties of an element, these tiny bits of matter are composed of even smaller parts, which are called subatomic particles. Okay, so this is a mind blower that a minute ago we thought that atoms were the smallest. But now we can see that we have even smaller parts inside an atom. Okay, and this is very important and mind-blowinger. Okay, that physicists have produced more than 100 types of particles from the atom. Okay, from high-speed collisions. Okay, and how cool is that? Okay, and even and this atom that we thought was on the smallest has become 100 different particles. Okay, but from all these 100 particles, we only 3 of them are relevant. Okay, which their names are electrons, protons, and neutrons. So protons and electrons have a 1 unit charge, which the symbol is positive. Okay, and the electron is negative. Okay, but now what about the neutron? Well, as the name implies, the neutron is electrically neutral. Okay, and protons are both protons and neutrons. Okay, are both tightly packed inside a dense core, which is the nucleus of an atom. Okay, which is called an atomic nucleus. Okay, so the protons give the nucleus a positive charge. Okay, because the neutrons are neutral and protons have +1 charge, so the sum of all the charges are +1. Okay, in the nucleus. and the electrons, which are rapidly moving, make a cloud of negative charge around the nucleus. And we all know opposite charges attract, and that holds the electron from running away from the atom. Okay. And so, in these two pictures, you can see two diagrams of an atom called helium. Okay, the second atom of the periodic table. Okay, and you can see here that electron, proton, and neutrons are the subatomic parts, and the proton and neutrons are actually condensed in or packed inside the nucleus of the atom. Okay, and but these pictures have a difference, and that is that the electron in the left diagram is a ball that is going in a line. Okay, but in the right picture we don't have any electrons, we just have a foggy or cloud something around the nucleus. Okay, so which one is correct? So the right one is correct because the electrons are moving very fast, and actually scientists can't even predict where these electrons are going to go next. Okay, so they aren't moving in a line. Okay, actually they are in some kind of a cloud shape something. Okay, and as you can see in this picture, the neutron and the proton are almost the same mass, but the neutron is a little bit more massive. Okay, it has more mass, but there is very little difference between these masses, so we just write them as 1. Okay, and I will tell you 1 watt. Okay, 1 gram, kilogram, or what. I will talk about that in a few seconds. Okay, and so each of them, okay, the protons and neutrons, are almost 1.7 multiplied by 10 to the negative minus or negative 24. Okay, grams. So, and as you might have noticed, grams is and other conventional units are not that good in describing the mass of objects. So, objects so small, okay, like atoms and protons and neutrons, okay, and molecules. So, scientists and anyone who is trying to calculate the atoms or smaller use a unit of measurement called Dalton. Okay, in other ways, this name Dalton is in the honor of John Dalton, the British scientist who helped develop the atomic theory around 1800. Okay, in the year 1800. And notice that Dalton is the same as atomic mass unit, or AMU, which is a unit, okay, you have encountered elsewhere. Okay, now neutrons and protons have masses close to 1 Dalton. Okay, so see, now are very easier. This is very easier because we couldn't even memorize 1.7 multiplied by 10 to the negative 24, I think it was. Okay, and we can only say 1 besides this big number. Okay, and some of you might be saying, what about the electron? How much does it have mass? Okay, because electron is the 1 to 2,000th of the mass of a neutron or proton, we can just ignore the electron when we are computing the total mass of an atom. Okay, so now you have learned about the electrons and protons and neutrons, and all the, not all, there's only three of the subatomic particles, and so that's all for this video, and until the next video, have good I wish you good learnings to you all.